The fundamental theorem of calculus, this is part 1, there's a part 2 of this which comes later. Consider the area under the graph y equals 3 from x equals 0 to x equals a, where a belongs to 1, 2, 3, 4 or 5. So if a is 1, we're looking at the area of this rectangle here. If a is 2, we're going from 0 to 2, so we're looking at this bigger rectangle just here. If a is 3, we're looking at this rectangle here, and so on. So we can see the width of this first rectangle is 1, the height is 3. That suggests the area is 3. So when x is 1, the area is 3. If we look at this rectangle just here, then the height is 3, the width is 2, and so we have an area of 6, and so on. So 3, 6, 9, 12, 15 as x goes 1, 2, 3, 4, 5. The table suggests that we could suggest the area function a of x is equal to 3x. Let's just try that. When x is 5, 3 lots of 5 are 15. So that seems to work. Consider the area under the graph of y equals 2x from x is 0 to x is a. And let's once again take a as 1, 2, 3, 4, 5. And so if we look at this, here's y equals 2x. So if a is 1, we're looking at this first triangle here, base 1, height 2, so the area would be 1. If a is 2, we're looking at this triangle just here, base 2, height 4, so the area of that would be 4. And continuing in that way, we build up a table of values. Now looking at this table, that means we could suggest an area function a of x is x squared. Now the thing to note that is that the integral of 3 dx is 3x. So this is y is 3, integrating 3 gives us 3x, which was our suggested area function. Over here we did exactly the same sort of thing. If we integrate 2x, we get x squared plus a constant. And so this was y equals 2x. We looked at various areas, and we found the area function was x squared. This leads us to the idea that the area under a line or curve is linked to the integral. This is indeed the case, and one of the fundamental theorem of calculus statements is that the integral from a to b of f of x dx, small f, is capital F of b minus capital F of a, where capital F is the antiderivative of small f. No c is required because there would be a plus c here and a plus c here, and since we're subtracting, they would just cancel out anyway. The integral from a to b of f of x dx is known as a definite integral. Now, we've already met these ideas in previous sections, but we're just pulling them all together here.